We've described what cons and empty can do, but it's still not clear why we should care. The reason is that we can make an itemization that describes lists. Here is the data definition of a list of numbers. We say that a list of numbers is either empty or cons number list of numbers. Then we give a quick interpretation. Very simple for this one. This is a list of numbers. Let's look at this definition. It is an itemization with two clauses. The first clause is just empty. That shouldn't seem too strange. Of course, an empty list is still a list. The much weirder idea is that a list of numbers is also a cons pair, where the first argument is a number and the second argument is another list. Because we reuse the data type being defined inside of its own data definition, we call this whole thing a recursive definition. Recursion is one of the most important ideas in this course, and it is absolutely necessary for moving forward with bigger programs. Because we have a data definition, we also need examples. Let's add a few. The simplest list of numbers is given by the first clause. We define a new constant named empty list and say it is the empty list. But let's make a more interesting example. For example, a 4-element list. So we say 4 elements is going to be cons 1, cons 6, cons 3, cons 5, empty. This may look strange, but it's a perfectly valid example of a list of numbers. We have a cons cell right here that is composed of two things, a number and another cons, or rather another list of numbers. You might be thinking, oh no, there's more than 2 parameters to that first cons cell. But there isn't. Look at how the parentheses work. The second argument to the first cons is just one cons cell that happens to have more stuff inside of it. That's perfectly okay according to our definition. One critical idea here is that in order to eventually end our list, the last thing has to be an empty list. That is the only way to terminate the nested cons, according to our definition from before. We can use the first and rest functions to get elements out of the list. So we can say the first of the 4 elements and find out that's 1. If we ask for the rest of the 4 elements, we find out that we get cons 6, cons 3, and cons 5, which is, of course, a list itself. We can also ask for the first of the rest of the 4 elements, which will return just 6. Notice that I can get the first of the rest of the 4-element list, but it makes no sense to ask for the first of the list. 4 elements. Because you're asking for the first of a number and not the first of a list. To walk all the way through the list, we need to call the rest function 4 times. 1, 2, 3, 4 on the 4 elements. And we cannot call the rest function, after that, we cannot call the rest function because there are no more elements. So if we try it, we'll end up with rest expects a non-empty list, and instead we are given the empty list.